So, what is data analytics? We can define data analytics as the process of collecting, cleaning, organizing, analyzing, and interpreting data to uncover insights and make informed decisions. Let's break down each component of this definition. First, collecting or obtaining data involves gathering data from various sources, such as databases, spreadsheets, and online platforms. The data collection can come in different formats, with more or less structure, which we'll learn more about later. When you collect data, it's important that the data is accurate and relevant to the questions you would like to answer with the data. Next, cleaning or scrubbing data involves removing any duplicates, inconsistencies, or errors that might be present in the data. This step is crucial to ensure that the data is accurate and can be used for analysis later on. Organizing your data involves sorting and categorizing the data into meaningful groups. This allows you to quickly and easily understand the data and identify trends and patterns. In this course, you'll learn how you can use spreadsheets to organize your data, and you'll see how much information you can gather from this. Analyzing data goes one step further and involves using statistical and mathematical methods to uncover insights and relationships within the data. This can involve creating charts, graphs, and tables to visualize the data and using algorithms to identify correlations and trends. Finally, interpreting data involves presenting the data in a way that's easy to understand. This can involve creating charts, graphs, and dashboards, and using different visualization techniques to help convey the insights generated from the data. Later in this program, you'll also learn how storytelling plays a big role in this phase. Interpreting data is all about conveying the story your data is telling and using that story to make decisions. Let's explore an example to help us further digest this definition. Anna owns a clothing boutique in New York called Bright Threads. She sells a mix of clothing brands and chooses items for her store that she believes her clients will like. She also sells online. One of the challenges Anna faces is buying the right number of items for her store every season. She wants to be able to offer enough variety for her clients and have items in different sizes, but she doesn't want to have too much stock, risking too many items being sold at a discount during the sales period. Anna can turn to data analytics for help. The data she has from past sales can help her make decisions when she has to buy the next season's stock. Anna uses software that registers every purchase in store and on her website. When an item is sold, the software automatically captures data on the sale price, the location of the sale, and some information about the product that was bought. So, Anna turns to that software to collect data from the past year. The software provides it to Anna in neatly labeled rows and columns. Because she's making decisions for the coming winter, she extracts the data related to last winter. Here's an extract of what the data looks like. It has the date of purchase, the clothing category, a description of the item that was sold, the cost of the item that Anna paid, the sale price, the profit, whether the sale happened in a boutique or online, the traffic source for online sales, which is a bit more information about how online purchasers found Anna's website, and the size of the item sold. This gives Anna the relevant information to estimate how much inventory she needs for different items for the coming winter. Now that Anna has collected the data she will work with, she inspects the data to evaluate whether there are any missing or confusing entries. She finds some inconsistencies in the size information, so she will focus on fixing that in the data cleaning step. For most items, sizes are reflected as small, medium, or large. But for some items, American sizing is used, numbers from 0 to 20. And there are also some items where Italian sizes are reported. Luckily, Anna can convert all these sizes easily. She decides to make all sizes consistent, and she changes the numbered sizes to the small to large categories. This way, the data is consistent, which will make it easier later on. Now Anna can organize her data. Anna will sort and categorize the data and find trends and patterns. Organizing the data in this way will better help Anna to make decisions for the coming winter's inventory. When Anna orders clothes for the next season, she orders from the different brands she usually carries in her store. So it's helpful for her to know which brands she sold the most of and which brands were most profitable for her. To figure that out, she sorts the data in the spreadsheet by brand and creates a quick chart to help her understand the information. Of course, there are many other ways in which Anna can organize her data, and there are other helpful charts she can create. Later, we'll learn all about them. But as we can already see here, this step is very helpful and equips Anna to make better decisions by using the data she has collected and organizing them. Anna can go a step further and perform some deeper analysis on the data. This step goes beyond categorizing the data as we did in the previous step. When you analyze data, you use more sophisticated statistical and mathematical models that help you deepen your understanding and insights. In Anna's case, the software she's using to monitor her inventory and sales is quite sophisticated. It has statistical and mathematical models built in, so Anna doesn't need to create a model herself. But she has learned what the software and the models can do for her, and she knows how to use them. One thing Anna is particularly interested in is knowing the trends in her sales. Is there any increase in the demand for certain clothing categories? And is there a certain size that her clients order most? Are some brands getting more trendy than others? Answers to these questions would help her to get her order for next winter right, so she doesn't get stuck with a large inventory at the end of the season. To answer these questions, her software has a prediction model programmed in. She tells the software to predict the sales for next winter based on the trends from the past 3 seasons. And her software provides her with a neat spreadsheet with predicted sales by item type, brand, and size. Now Anna has everything she needs to make her decisions. She summarizes the information she got from the software predictions and from the categorization work she did earlier, and she shares it over a morning coffee with her associate. She uses the charts she created and the spreadsheet the software provided her, and tells her associate how she plans to go about ordering the inventory for the coming winter, based on the insights she gained. Armed with this information, Anna and her associate go to work and browse the new collections the different clothing brands present. Using their fashion savvy, their understanding of their clients, and their data insights, they put together the collection for the next winter. This was just a very simple example of using data analytics to make decisions. Of course, sometimes data analysis can be a lot more complex, but it doesn't have to be. We all make decisions based on data and observations all the time, and that's not too different from what Anna did here. For many of us, data analytics is part of our daily work and routine, but there are people who almost exclusively focus on data analytics in their roles as data analysts. In what follows, we'll take a closer look at the job of a data analyst and the different forms it can take. I will see you there.